3 coplanar points, and bam, there's the radius of the Earth.
On the level.
The way I phrase it is a monument to the curvature of the Earth. It
I
really
totally
is.
agree with
Level.
It really
totally
is.
agree with
Level.
And bam, there's the radius of the Earth.
Right, Louis.
What's that?
The start of this is right, 7 facts that we have to get established first. These called the we call them the axioms of right line geometry, right?
Okay.
But the step 1 is to make you aware. Right now, this is on the if you're watching the live stream or the stream that I'm doing through Discord, is this is the website. This is our website on the level. And
Hell yeah.
This is the reality/model test type thing. Right, okay. So the first bit is cognitive dissonance. You've heard of it.
Oh yeah.
Right. Cognitive dissonance is a mental conflict that occurs when beliefs or assumptions are contradicted by new information. Right? The unease or tension. Go on.
Yeah.
You want me to finish, right? Reading it first.
Yeah, that's
okay.
Right.
The unease or tension that the conflict arouses in people is relieved by one of several defensive maneuvers. Right? They reject, explain away, or avoid the new information, persuade themselves that no conflict really exists, or reconcile the differences, which is a strange one, or they resort to any other defensive means of preserving stability or order, right?
Right.
Or they order their conceptions of the world and themselves. So they preserve what they already know, right, within cognitive dissonance.
Yeah. I was going to say, I don't think it has to be new information. It just has to be information that you were not thinking about in the previous moment.
Absolutely, right? It's information that was there, and then some information causes you to have a conflict of what was already known, and that conflicts with normally the new information, but I mean it could be a realization of that information that you already know. Right, and it was this concept was developed in the 1950s, so it's not new. Well, it is pretty new.
I'm not totally on board with how psychology draws lines in the sand and defines things, but this is fine.
Yeah, but you do understand that there is right. There's a mental process that goes on within all of us have it that we're not really aware of, right?
Yeah. I would say you can gain more awareness of your internal environment, but a lot of it is, most of the time, it goes on without us thinking about it.
Yeah, you not very often are we by ourselves. We are ruled by this cognitive dissonance. It's a mental conflict, right?
Well, I wouldn't say that's necessarily true. I would say your beliefs will change how you perceive and interpret information in the world, and as a result, your beliefs can control you. They can control what you think of what you're seeing, and by knowing that, and by consciously identifying your beliefs, you can take the energy out of them, and that can allow you to have a more neutral perception of reality.
Cool. So it sounds like you've got a good grasp of that mental idea, right? It's because a lot of this stuff is psychological, right? You know, like what you believe versus what you know or what you can prove, right? The reality versus belief.
One thing that a criticism I have of modern psychology is that they have tried to categorize people into personality types, and I don't like that. I think it's more useful to talk about people in terms of what they believe. I think that's a much better way to analyze someone's psychology. And so, yeah, I think analyzing things in terms of beliefs is sort of at odds with how psychology is doing things right now.
Okay.
I think the 2 points of view are at odds with each other.
Right. Well, I
'Cause one of
wouldn't.
them-
We're not debating the psychology of anything, right? All of that says is that
Yeah,
cognitive
I
dissonance
know, I
occurs,
understand.
and there's a multitude of different ways, right? Each individual, rather than groupthink, right? Each individual have a different reaction to this sort of cognitive dissonance when it occurs, right? I think that's what it was trying to say. That you
Yeah,
never
yeah.
really know how somebody's going to take this. I mean,
Right.
yeah.
And yeah. So if you encounter information that is at odds with one of your strongly held beliefs, then that belief is going to cause you to try and hang on to that belief.
I imagine so, yeah. That's why I said the reconcile part of it is,
Right.
I don't know, you have to be, in my mind, you have to be a very special, or you have to have gone through a few different processes for you to be able to reconcile something like that instantly, right, without cognitive dis.
Yeah. I would say it's impossible.
Well, I don't know. Within psychology, it's people's minds. I don't think you could ever use the state impossible. That's when you're talking about somebody's mental state. I mean, there's all sorts, isn't there? How could you account for anything like that?
For somebody to not experience any conflict at all, they would either have to have no commitment to any of their beliefs, or
Right.
their mind would have to just work entirely differently.
Open.
Yeah.
Yeah.
Which, as a general rule, doesn't ever happen.
Really?
Well,
Yeah,
I think
generally
some
speaking, yeah.
people may think differently. I mean, for you to think that it doesn't ever happen must mean that you've already closed it off. Because that's what I find that people imagine other people to be just like them. So, but where is it?
No. Yeah, sorry. No, not everybody. People are certainly different.
So
And
there could be a chance that somebody could be like that, what you just said, but we don't know, right?
I've never met someone. I've never met anyone like that, even close.
Okay.
Yeah.
Okay, right. Well, let's go. You ready now then? Now that you're aware of that
Yeah.
and how grave it can be, we don't want to be making any gem pandas or anything like that. People crazed lunatics.
He's
Super
not
trolls.
that bad.
Triggered troll.
Yeah,
Yeah, but some
I like
people
him.
do
He's
get
pretty
triggered,
cool.
don't they?
I think he plays a character.
I mean, sometimes he gets mad, but I mean, you get mad too. So I mean, it's not. I don't know. We don't need to talk about that right now.
Okay. Right, well, here we go then. Step 1. A straight line is a right line with zero curvature, right? I'll read the definition that we've got here. A right line is that which lies evenly between its extreme points, that is, without curvature in any direction, being the shortest path between those 2 points, never deviating from that path.
Okay, so why did you call it a right line? Because that definition is just a line. That's just a line.
A right line is a straight line.
Any line is a straight line.
Any
A
curved
curved line isn't a straight line.
A
is it?
curved line is not a line.
Yes, it is. A curved line is a curved line.
No,
A straight line is a straight line, and a right line is also a straight line. Because a right line, right, has to be 2 right lines at perpendicular, right? So in order to form a right angle, that's why it's called the right line. Because it being a straight line has a perpendicular that forms a right angle. There's no way you can have a curved line to form a right angle. That's why we use right line, because
that's
turns
not
it
true.
into the reality of a right line making a right angle.
A curved line could form a right angle
It
with
couldn't.
another line.
A right angle?
Yes.
No. That's impossible. You'd have to use a straight line next to that curve to try to measure an angle, but you can't do anything with that curve.
Sure you can. You just look at the intersection.
But like, forget about the angles right now, right? We're just talking about a straight line. What do you think about the definition?
The definition you gave is just a definition of a line.
A straight line.
There are no unstraight lines. They're not lines if they're not.
What do you
straight.
call a curved line?
You call it an arc.
You want to call it an arc? But that's in relation to a circle, right?
Right. So anytime we ever hear you
necessarily.
saying line, or don't need to say straight line, do you? Anytime you say straight line or line, you mean straight line.
Well, I would just mean a line.
Does line mean straight?
Yes.
Right.
An arc means curved.
Exactly.
Okay. Right. So from now on, when we say straight line or right line, we definitely don't mean a curved line. You understand that?
Or an arc.
And you don't mean that either, do you?
No.
From now on, anytime you're ever going to talk about a curved line, you will specifically call it an arc or a curved line, won't you?
No, not necessarily, because I don't always speak in technical jargon.
Right, so we're talking about from going forward, this is the beginning, from first principles. A straight line. Are we of the understanding that when we use the term straight line, we are meaning a right line is that which lies evenly between its extreme points, that is, without curvature in any direction, being the shortest path between those 2 points, never deviating from that path. Right?
Yeah,
And also, let me finish.
Yeah.
This is not a concept, but a fact of reality and basic logic.
Everything you just said seems pretty redundant and unnecessary, but I understand.
It's his
what
first
you're
principles, Louis. This is not we're not putting it here because it's redundant. This is first principles for us to get established from first principles.
Yeah.
Well, right.
This is going to take a little bit longer than you think initially, Louis, because we're getting stuck on the meaning of a straight line. I mean, it's okay. I quite like the idea of hashing out.
So an example of how it's redundant is you could redefine this and just say a line is the shortest distance between 2 points. And that you wouldn't have to say anything else. Everything that you have here is covered by that.
Yeah, that's why I've been so thorough, to make it extremely certain that nobody can come along later and say, well, you just said line. I thought you meant curved line. So this is why we say specifically straight, right
Very
lines.
unique for each individual.
Is it okay to have a debate with ambiguous meanings and terms?
Well, if your whole point is to create these well-defined terms to avoid confusion, then yeah, it is important.
Cool.
Okay.
So would you agree to it then?
I mean, it's just an overly complicated definition, but yeah, I agree with it. Yeah.
Okay. Well,
We
can go further into straight lines if you want.
Well, because you can have a line.
We've got a whole page here.
If you have a straight line, you need a word for a line that isn't straight.
Well, it's just not a line, right?
But saying something isn't something is not saying what that something is. And this is why the definitions are the way they are. So if you say, oh, well, it's not horizontal, they'd be like, well, what is it? I think, well, it's not horizontal, right? So when you just say what it isn't, that's where you get into the confusion. That's why you're trying
if you have a continuous two-dimensional object that is not a line, it's either an arc or a combination.
Louis, stop. It's a plane.
I was almost done.
Two dimension is a plane.
No, 2-dimension is a line.
No.
1 dimension is a point. 2 dimensions is a line.
Louis.
3 dimensions
Louis,
is a plane.
please. A point is
Oh no,
that.
you're right. You're right. My mistake. You're right.
Okay, so a point is that of which has no parts,
Right.
nothing. A line is
Right,
one-dimensional,
yeah.
and a plane
So if you have
is two-dimensional.
if you have a single one-dimensional
This
segment that just
this is
continues
meant
on,
to be.
but it's not a line.
This is
But
meant
it's
to be
not
a presentation.
Hang on.
Okay. Go on.
Line there, it can only be an arc or an arc and combination of line segments or a combination of lines. It's not at all. There, like that's what it would be. There are no other combinations of things it could be.
Okay, do we need to carry on? Because I've got more. Do you want more for a straight line?
No, I'm fine. I'm just sharing with you my point of view about what I'm seeing.
Are you? Is he roboting for everyone or?
No, he's fine for me.
Oh. Okay. It says in this, Louis. It says the statements we prove are called theorems, but it's not possible to prove every statement. If we had to, there would be no end. Rather, to prove or explain anything is to do so in terms of something simpler, something that we must acknowledge and accept. They are called postulates or axioms. Similarly, it is not possible to give a verbal definition of every word because we must already understand the words in which a definition is framed. An example from arithmetic is the impossibility of defining 1. Try it, it says, but don't try it just yet. That does not mean you don't understand the word 1, right? An example from geometry is a definition of a straight line. This is basic logic, right? Is there something we know better or is more fundamental on which a definition could be based? So you have to have a definition of the word straight. You have to. Otherwise you can't really define anything, can you?
I mean, you could have concepts of a whole lot of other things besides straight and still be able to define.
We are just talking about straight, right? Okay, I'll give you an example. A plumb bob. Yeah?
Yeah.
Right, now what is that? Is that a straight line?
Yeah, pretty
Right,
good.
like a straight line, straight line.
Yep.
No curve.
It's a line.
In any direction.
Yeah.
Okay, now how would you define a circle? How would you describe a circle?
A circle is points that are equidistant from a center. All points equidistant from a center.
A point is that of which has no parts.
Sure. I mean, but now you're just defining out of existence, whatever the circle is.
Well, I'd say in order to describe a circle, you would need a radius, a center point, and the distance from that center.
Yeah, that's what I said.
Right, now is a radius a straight line?
Yes.
Any curvature?
No.
Okay. So we do know what a straight line is, right? So going forwards from here, we know the definition of a straight line, and a straight line has no curvature.
It's just so the tone of voice you have saying all this stuff is.
Well, I'm sorry.
It's off-putting.
I'm sorry, I don't have it. I don't
mildly...
have another voice.
Yes, you do.
Okay. So we've done straight line. Now we're on to perpendicular.
Okay.
Right.
Which number is this?
Obviously, this is number 2.
All right.
Okay. Perpendicular. because we've done a straight line. Now we progress one step. This is an axiomatic right line geometry system. When a straight line standing on another straight line makes the adjacent angles equal to one another, each of the angles is called a right angle, and the straight line which stands on the other is called perpendicular to it. You heard it before, didn't you?
Yeah, that's not quite the same wording that was used before, but yeah, sure.
Okay, and as stated in axiom 11, all right angles are equal, therefore the lines must be straight.
Yep.
Brilliant. Also shows that you need two straight lines to make an angle. Because you can't, to make an angle, you can't have all right angles being equal if any of the lines are curved, can you? Because you can't have an angle like that. So,
no, that you can. The angle is only defined by the intersection
of the lines, the two straight lines.
The lines or whatever is beyond the intersection doesn't have to be a line. The angle is just at the intersection.
No, the angle is at the intersection of two straight lines. There's two right angles, right, can only be formed by two straight lines at perpendicular to each other, forming a right angle.
It is true that straight lines will form that, but is this all being said in the context, these are rules that everyone knows must be true? Because if that's where this is coming from, I'm just going to disagree with that premise.
Right, so all we're doing is going through an axiomatic. First off, straight lines, which we've dealt with, right? Straight lines are straight. Next step is perpendicular, is the forming of right angles. Now, in order to form a right angle, you need two right lines, two straight lines, in a very particular position. Right? These are maximally opposed to each other, forming four equal right angles. Now, if the lines weren't straight, you would not be able to have four equal right angles.
That's not true.
It's an impossibility.
Oh yeah. You're right. No. It's possible. You're just wrong.
Go on
about
then,
that.
show me. Do a quick drawing of you doing two straight lines, or maybe not straight lines, making four equal right angles, making all of the right angles equal. I'll say now it's impossible. It can't be done. Not possible.
That's fine.
You need two straight lines. This is what I'm trying to do. We're going through it. It's first principles, straight lines, and I'm giving you a proof at every step of the way. Right, so first off, we started off with a proof of a straight line. I showed you two lines that you agreed with that must be straight. A radius and a vertical. This one is two straight lines are the only lines that can come together to form equal right angles.
Yeah, and I'm just telling you that's not true. You can have right angles with curves, with arc segments or circles or any curved object can form a 90-degree angle with another one.
I'm telling you now, it's in mathematics, the foundation of mathematics. All right angles are equal, and
it's true.
That's an axiom. That's an axiom.
Yeah.
And the only way, logically, you can do that is with two straight lines.
That's not true. It's not the only way you can do it.
Go on then. I would offer up. Now's your chance to just show us how you can do that, please.
So draw a circle and then put a plus sign overlapping it, crossing through the center. And every line that crosses the arc of the circle will be at 90 degrees to the circle.
The circle is curved.
Yeah.
and the right angles would be at the center of the circle.
There would be right
With
angles
those
at the
two?
center, but there are
Yeah.
also right angles at the intersections of the lines with the circle.
Okay, but would that make the ones on the inside of the circle, crossed by the arc, shorter?
Yes.
They wouldn't be the same angle as
They
the
would be
ones
the
on
same.
the outside, because there's a
They would be.
curvature.
That's not correct. They would be.
Do you want me to? I'll go onto the board, right? Hopefully this doesn't ruin everybody's camera. Oh, wait a minute. I'm going to have to change that. Video is not working. Louis, have you got a drawing of it, or am I still gonna have to try and sort this out for you?
Feel free to draw it.
Okay. No, I've not even got it open, have I? Alright, I'll draw it on the board and then I'll have to take a picture of it.
Camera went off there.
Yeah. I'll have to do it on the board and then take a picture of it. It's not working.
Gotcha.
I just wanted to say just one thing. Fuck you, Clary.
Right. Right, coming in the which one? Debate discussion. Are you drawing it as well, Louis?
I don't know if he's cutting out for anybody else, but better be cutting out.
Am I? Is that better?
Bev, I DM'd you an image, and you can put it up that way.
Right, you've got straight lines there, dude.
Yeah, there's also perpendicular angles with the circles. The circles are perpendicular to each other.
Right.
The source for this image is from geogebra.org.
Okay, can you see in the debate discussion?
Yes.
You see that the ones on the top would be larger than the ones on the bottom of the curve. Yeah, it is. Can you not see that they are smaller than the ones
angle
on top? They are not the same size. They would not be equal. They have to be equal because all right angles are equal. They are not.
Are you just going to continue
equal.
to repeat yourself?
Yeah.
All right, then I won't respond.
Go on. I'm going to put your picture up now so everybody else can have a look at that.
All right. The angle is not determined by the arc extending away from the intersection. It's determined by the intersection.
By the straight line that you've got.
Even
you've got on yours, you've got two straight lines. You've got a radius and then you have a tangent. The tangent is perpendicular. That's why it's there. That is also a rule of the geometry, right?
Sure.
Because it's proposition, right? It's propositioned in book 3 that the tangent is perpendicular to the radius at the
All right.
point of intersection
Well, this is an example. This is an example
of
how
two straight
curved-
lines.
These are curved surfaces. The circles, they're curved, and they are perpendicular to each other. This is an example of how perpendicular angles can be formed by curved surfaces.
No, they are two tangents. Those are straight lines that you can see. You've drawn the right angle at the intersection of those two straight lines.
No, the right angle is
Yes,
at
Louis.
the intersection of the circles.
No. The right angle is between the radius and the tangent on both of them.
Right. You can just reject that this is just as valid in mathematics as what you're talking about, but that's fine. I don't.
The thing there, again, I'll say it again, Louis, the thing there that is perpendicular to each other are the radius, straight line, and tangent, straight line. Two
That is a
straight
true statement.
lines at right angles to each other, perpendicular.
Yep, that is a true statement, Bev.
Right, now the
It's
circles
also
have
true-
just been drawn.
It's also true that the circles are perpendicular to each other.
You can
and
call the
intersections-
circles perpendicular if you want, but perpendicular is the intersection of two straight lines.
Oh, Bev, it just sounds to me like you're being selective about which math you recognize as legitimate or not.
Where's your definition?
Oh, let me go get my math book.
Perpendicular, please.
Oh, my definition for perpendicular?
Yes,
90
please.
degrees.
Right angles, straight lines. Two right lines, the intersection making a right
Oh,
angle.
were you asking me for my definition or the one you want me to pretend is
No,
true?
just the mathematical definition. We need to progress, Louis.
Okay, here, I'll make it real easy for you. Okay, I accept your definition.
Okay, brilliant. We'll go on then. Seeing as straight lines and perpendicular are the mathematical definition.
They are part of the mathematical definition.
They are the definition. I've read it out to you.
You're just, man, you're
The actual
just wrong.
definition.
You're just incorrect.
Okay. You will get corrected. Okay, ready to go? Now we're doing these. Those were two. They were the two geometrical statements at the beginning, right? That was just purely geometry, just to see how well you could cope with the basic geometry.
Oh, cope.
Yep.
Oh.
You did
Seems-
okay.
it seems like you're
We've
giving
seen
me-
people try much harder or to try and defend.
There's no defending, because what you're saying is technically not true, or are technically true. Like, what you're showing me is part of mathematics. Where you're wrong is where you say this is all that there is.
I didn't say this is all there is. I just said, would you agree with it? And you kept saying about circles. Both times we were talking
Yeah, no,
about straight
I
lines.
agree.
You started talking about circles. We went
Yeah,
to
but-
talk about perpendicular. You wanted to talk about circles.
Bev,
That's
Bev,
fine.
you
It's
know
fine.
why I brought that up.
Yeah, cog dis. We went over it
No,
at the beginning.
it's not cog dis, Bev.
Okay.
It's that you're presenting this as if this is the truth. This
No.
is what the
Dude.
established mathematics say. And
No.
I'm telling you, it's not everything that they say. And then when I said that, you disagreed with that.
You wanted to come for the presentation, didn't you? And I did tell you at the beginning, the cog dis, there's an element that you might not be in control of yourself. Please be careful.
Yeah.
Mm-hmm.
Yeah, thank you for that warning.
So you're ready now for the next step. We come to reality now. We've done
We've
the
been in
geometry.
reality the whole time.
We've just been doing geometry, straight lines and perpendiculars. That's pure geometry. Now
I'm
we're
sorry.
actually coming
Oh,
into
I
reality,
see.
right? Plumb bob and
Okay.
perpendiculars, perpendicles, if you like.
Okay.
A perpendicle is anything hanging down by a straight line. Plumb bob is a tool for establishing a vertical reference. This is used in reality daily by many people. A vertical line is a straight line.
Yep. All lines are straight. Yep.
Okay, so you would agree with that then? That's
Yeah.
easy. That's always
Yeah, I would.
that's a good one, right? Yeah. People like the reality one. Level. Level is a straight line on a horizontal plane. A level is a tool for establishing a horizontal plane of reference in which vertical heights can be measured. An instrument for determining whether a surface is evenly horizontal. From Latin, a balance level.
Sure.
Yeah. That's a good one for you as well then.
No, there's nothing wrong with it. I mean, I can see exactly where this is going to end up creating problems further on down the line. But yeah, no, there's nothing technically wrong with this.
Okay, good. Okay, next one. Perpendicularity. That's a good word. Big word. It's all right. The relationship between reality and geometry comes apparent with the right line relationship of the two frames of reference we use in everyday life. Level and plumb are perpendicular. Vertical and horizontal are perpendicular. It's not coincidence. Geometry is reality.
Sure.
Okay.
Well, no. I mean, if geometry is reality, then we've been in reality this whole time.
Yeah, that's what the geometry is based on logic, and logic is based on reality, right? We use.
Yep. So when I said that earlier, and you nitpicked and said, no, that was all in our heads before. Now we're coming into reality.
This
now,
right line geometry is the geometry of reality. That's where we're going to, right?
Yeah, we've been in reality the whole time.
Yeah, we're always in reality.
Yeah, exactly. Which is what I said before.
Okay, so a water level is any device utilizing the surface of liquid water to establish a horizontal plane of reference. The water level is lower tech than the more modern levels, but it can be more accurate over long distances and works without a sight line, such as around corners.
I would
wait a minute. 2 ends of a water level equals 2 points of a straight line.
I would change
at an even altitude.
Dude, can you just like actually read in a natural cadence?
This is.
I would have changed the word any. I would have said a water level is a device.
Why?
Because then you're not backing yourself into a potential corner.
Why?
Because all somebody has to do is find a device that uses water that isn't a level.
No, it says, I'll read it again. A water level is any device utilizing the surface of liquid water to establish a horizontal plane of reference.
Mm-hmm.
So the water level is any device. As long as it uses water to establish a horizontal plane of reference, then you can call it a water level.
I mean, it's not an important thing to nitpick, but I'm just saying I would still just have it be a device.
What would you call a device that uses water to establish a horizontal plane of reference?
Oh, I'd call it a level.
A water level.
I mean, I wouldn't see the need to create that classification, but you could.
Well, it's not an auto level, right? That's not a water level because it doesn't use the surface of liquid water to establish a horizontal plane of reference because it's an auto level, not a water level.
This doesn't have to be a significant point of conversation.
But it is the step in the axiomatic system that we're going through at the minute. The presentation that you've just come round for. Are you trying to critique it?
Yeah, this is just my natural reaction to what I'm
Okay.
seeing.
Well, what
but-
you should do then, Louis, you should do your own after this,
I
right?
have
And
no interest in
refine
doing
it and make it better for yourself.
Yeah, sure, I'll do that.
Brilliant. Okay. So a water level establishes a horizontal plane of reference. That's what the tool does, yeah?
Yeah.
Okay. Now, all horizontals are parallel to the plane of the horizon, right? Horizontal means parallel
I disagree.
to the plane of the horizon. The relationship is
disagree.
clear and obvious.
Yeah, I disagree.
Okay. How about this then? Straight lines which are parallel to the same straight line are parallel to each other.
Yeah, parallel lines are parallel. Yeah.
No. Straight lines which are parallel to the same straight line are parallel to each other. It's proposition 30.
Parallel lines.
Straight
are-
lines
are
which
parallel.
are parallel to the same straight line are parallel to each other.
So you've got 3 lines and they're all parallel.
Straight lines. Yeah?
There aren't any non-straight lines, Bev.
Okay. Well, that's what I was saying. However you want to picture them. Straight lines. However many. Yeah? Get them in your mind. Straight lines which are parallel to the same straight line. So, first off, start with the same straight line. And then get some straight lines that are parallel to that same straight line. Then those lines will be parallel to each other.
Yeah.
Yep.
Mind-blowing.
Okay. Now, horizontals are parallel to the plane of the horizon.
Yeah, that's not true.
It's not true. Do you want to have a look at the mathematical definition of the word horizontal?
I have no interest in that, but I have a feeling that if I don't say yes, you won't continue with the presentation.
I'm just asking.
Yeah, I just answered.
You do trust mathematics.
Do I trust it? Yeah, sure. That's a good enough word.
So if we were to go anywhere for the definition of anything, we should always check first mathematics. Because you
no.
trust that the most, right?
I would not agree with that statement. No.
But you would not trust mathematics the most.
No. The previous statement, you genius.
Which was that?
The one about if we want to know the definition of anything, the first place we should go is mathematics. I would not agree with that
We
statement.
go and check there first. I mean, obviously, we're not going to find dog in mathematics.
I wouldn't go there for 99% of the things I might want to know the definition of. But if I'm doing something with math, yeah, I'd probably go there.
Okay, so should we type in horizontal mathematics and see what the definition is? And
Hang on.
would you trust that?
Say it again.
If we were to put in a search now, horizontal mathematics, would you be happy with the definition that we came up with?
I don't know. It'd depend if it conflicted with
Your
my
model.
previous conception about what our conversation was about and the reasons I objected to the previous statement.
Okay, so we're talking about all horizontals being parallel to the plane of the horizon.
Right. Yeah.
Yes.
I would not necessarily agree with that.
So if we were to look for mathematical definitions of the word horizontal, what do you think we might find?
You're going to find, I mean, we could just use the definitions that exist previously in this document. The
For
ones,
horizontal.
the ones that say horizontal is perpendicular to the vertical. That one's fine. That one's fine. The problem is, how are you establishing what the plane of the horizon is?
It would just be a straight line, wouldn't it? A plane is a straight line, right?
A plane is not a straight line.
All the
and it
straight
would
line
matter
would be all
where-
straight lines on the plane.
Yeah, so not all lines are parallel. So therefore, the way you're determining the plane of the horizon is going to determine if it's parallel with the horizontal.
Okay, well, I'm just going to do a horizontal maths and see what we come up with. What is horizontal? Definition and with examples. K5 learning. Doesn't sound like it's kindergarten. I don't know. What do you see? Horizontal. Standing up.
Oh, there they are. Hell yeah. This is what we need.
Yeah. I mean, it's pretty kid stuff, isn't it?
Yeah, horizontal is opposite of vertical. In geometry,
Anything
we use the word... Yep.
Parallel to the horizon is called horizontal. Oh, hey,
Hell
is that
yeah,
okay?
dude.
Parallel to the horizon.
We found it on this website. I guess we better ignore all of the previous criticisms.
Okay, wait a minute. All right, let's go. I'll go. We'll find another one if that looks horizontal.
Yeah. Let's find all of the definitions
going
that
side to
just
side.
allow you to ignore the criticism I just gave you.
Parallel to the horizon.
Yeah, let's just ignore the criticism I gave you.
Maths is fun. Horizontal math.
All right, so for example, if you're gonna
in geometry, a horizontal line is one which runs from left to right across the page. It comes from the word horizon.
Are you interested in my response?
In the sense that horizontal lines are parallel to the horizon.
Right. So when you phrase the question, are your horizontals parallel to the horizontal plane? That conjures up a few different scenarios. One is where you're just drawing a line from like your far extreme left to your far extreme right, and that line, that would be parallel with the horizontal.
Oh, we've got one here for you as well.
If it's from your position to the horizon, then that line is not parallel with the horizontal.
Right. Do you think you could do this? Do you want me to get you this test? Just so.
Did you hear what I just said, or are you just ignoring it?
You said something about children in.
So you didn't hear it. Okay.
Year 3.
So what I said was, if you draw the horizontal plane, the horizon plane. Well, yeah, you said the plane of the horizon. If you draw that from you.
Yeah, they'd be parallel to the plane of the horizon, because you know what a plane is. 2-dimensional surface, right?
To the horizon, off at the...
Oh. Are you all right? Is that just me?
Did you hear me? You cut me off at the very end.
I didn't cut you off. You're lagging, or
you did. You cut me off.
Are you okay? Is he okay for everyone, or is he bad roboting?
Breaking up a little bit, but not roboting.
Okay, so
he dropped out that last bit's why he thinks you interrupted him. He did drop that out.
So all I said was, if you establish your plane of the horizon based on you to the horizon, then that line is not going to be parallel with the horizontal.
Do you know what a plane is?
Yeah.
2-dimensional.
Are you keep asking me stupid questions that we've already established and agreed the definition of?
2-dimensional surface that extends infinitely far in all directions.
Yes.
Right, so that's a plane. So parallel to that plane, doesn't really matter which angle or straight line you're going to put a horizontal. It would be parallel to the plane of the horizon. That's what maths says.
No, it wouldn't be.
You don't agree with all the mathematical things that we've found so far. Do you have a mathematical definition? Do you have a mathematical definition to say that horizontals aren't parallel to the plane of the horizon?
All right. So if you have the horizon and it's not straight, perfectly out in front of you, which I know we may disagree on this. It's actually not. Then from your eye to the horizon is an ever so slightly sloping down line. And in that situation, it would not be parallel to a truly horizontal line. But you would still be able to call it the plane of the horizon. So do you see where my objection is?
This is just a simple logical statement.
I understand that. Are you planning on, was that supposed to be relevant to what I just said?
It was what you said relevant to straight lines which are parallel to the same straight line being parallel to each other.
We actually moved past that section.
Did you?
Yeah, you did actually. I have no control over this presentation.
This is the point in the matter, right? That shows you that horizontals are parallel to each other.
Yes, yeah, we actually talked about this already.
Yes, we did. Yes.
Yeah, we did, Bev. So you can scroll further down the page to where we actually were.
What? No, this is where we were. The horizontals. There's no further down the page. This is the last one. Step 7. Once we do this, you're ready to go into the next stage.
Okay, then what you asked me was after this. You asked me about the plane of the horizon being parallel with all horizontals.
Yes.
And
I made a statement, Louis. All horizontals are parallel to the plane of the horizon.
Right, and that this, depending on how you establish the plane of the horizon, that's just not true.
But that's the mathematical definition of horizontal.
Yeah, you know what? You know what's funny? The mathematical definition doesn't describe how.
Oh, off again.
Did he cut off?
Here, so that we all understand what we're talking about here. I'm just trying to establish
cut off then,
clear understanding. Yeah, I understand. So I'm repeating myself.
Yeah.
Yeah, there was like 15 seconds of you not coming.
All I'm saying is that depending on how you establish the plane of the horizon, it might not parallel with the horizontal. That's all I'm saying. Oh my gosh, is it okay? And the mathematical definitions that we all looked at, did not tell you how they established that.
No, it just said that horizontals are parallel to the plane of the horizon.
Yes, that is what it said.
And you say they're not right now. So
no, I said depending on how you establish the plane of the horizon, they might not be.
Okay, well, which way would you establish the plane of the horizon?
I don't know. I'm not giving the presentation.
Would you tilt it from one side to the other? It's a
I'm
plane.
not giving. Are you just this way that you speak, where you say something and then stop, is really frustrating.
When I ask a question.
No, where you say something and then stop and then start saying something again. After that pause is an implicit invitation for me to respond. That is very frustrating.
To you?
Yes.
Yeah.
The person you're conversing with.
Really sorry. Are we ready to move on?
I'm just criticizing your ability to be polite.
You've been criticizing quite a lot. Yes, you have.
Okay, then.
So this is the cog dis part, right? So
no, it's not.
Yeah, it is.
Nothing you've said is in any way challenging to the beliefs I have.
Okay. Well, the plane of the horizon. Can we start that one first? Because we all know horizontals are definitely straight lines, right?
Sure.
Okay.
Yeah. So how are you establishing?
So the problem you have must be how you establish the plane of the horizon. Now, first off, we understand what a plane is, right?
No.
Okay, it's two-dimensional.
Wow, I had no idea.
Okay, so we know it's two-dimensional. Now, Does it have a tilt to it? And which tilt do you imagine the plane of the horizon might have to make it not parallel to the horizon, horizontals?
Well, if you establish the plane based off of the observer's line of sight to the horizon, that's not going to be horizontal. So that is how. And I explained that already.
So when I have a level in front of me and I'm holding it and I'm looking at the horizon, the plane of the horizon, are you saying the horizontal level that I'm holding isn't parallel to the plane of the horizon?
It depends on how you're establishing the plane of the horizon, Bev.
I'm not establishing the plane of the horizon. The plane of the horizon is always there. It's what all horizontals are parallel to.
Any line that's parallel to a horizontal line is going to be parallel to it, whether it's the plane of the horizon or not.
Okay, so any straight line that horizontals are parallel to would make all horizontals parallel to each other, wouldn't it?
No,
yes,
that's
from
not
the
true
logical
either.
statement, straight lines which are parallel to the same straight line are parallel to each other.
Yeah, that's not true.
As a logical statement? Because I think it is. I think it's
No,
provably
it's not,
true.
Because all horizontals require, at all points on the surface of the Earth, horizontal to be established.
You've just invoked an Earth.
And because the Earth is a sphere, they will not be parallel.
Okay, so you're saying that horizontals cannot, because obviously a horizontal is a straight line, and you obviously think the plane of the horizon, but that's plane's 2D. Like, you can't curve a plane, can you?
Yes, that is correct, Bev.
Okay, well, so where's the? How do you do a plane of the horizon?
Actually, I think you might be able to curve.
You might be able to curve a 2-dimensional plane.
Yes.
A curved plane.
See.
I'm not surely
sure.
That's got to be 3D.
I'm not sure how they classify that.
I would say that would be a mind trick. That I don't think you'd be able to do it in reality.
You might just not.
You can't put a 3rd-dimensional curve into a 2-dimensional plane whilst keeping it a 2-dimensional.
In the same way that you don't accept perpendicular circles, you may not accept a curved plane.
Do you have any? Should I go into look for a mathematical definition of a plane now? Or what do you reckon?
That's up to you, man.
Right. Well, what do you think? Do you think you could find a mathematical definition of a curved plane if you were to look for plane?
That's what I'm doing. I'm not sure. I'm vaguely remembering something from when I was in school, but I'm not sure about what I'm remembering, so I'm not confident to say one way or the other.
Okay. Well, I mean, this is pretty vital for the next step. But
not really.
We could hit the board, and I could show you logical fallacy to sort of prove this if you want. If you're struggling to find a 2D definition of it. This was a logical statement.
It's not actually
put on a T-shirt, you know.
You put anything on a T-shirt and someone would buy it. They would define their own meaning.
I'll stop streaming that because you've obviously so I'll get you the there it is.
Yeah, okay. No. There are no 2-dimensional curved planes.
Okay. So
Yeah,
it's good.
that's technically correct.
Okay. So in order for a horizontal to be parallel with a plane, in order for it to be not parallel with a plane, the plane would have to have some sort of a tilt away from the horizontal, wouldn't it?
Yes. Yeah.
Okay. Does the horizon, the plane of the horizon, have a tilt?
Well, I'm not sure how this is being thought about, but based on our disagreements recently, I'm going to assume it's not the way that I was thinking about it that would cause a problem. So, no, the plane of the horizon does not have a tilt. I'm assuming that's just simply being established by drawing a line from your extreme left or,
It's a
the
plane.
extremes of your horizon.
It's a plane. You could almost like do it from your eyes that way as well, couldn't you? Because it's a plane.
Anything you establish visually, you're going to do with your eyes. So I'm not sure what you mean by that.
The plane of the horizon, like it's a two-dimensional
I'm
plane
aware
of the
of the
horizon.
subject matter of what we're talking about, Bev.
Okay, so to which all horizontals would be parallel.
Bev, it's like you're not actually hearing the nuance in the discussion we're having, and you're just pretending it doesn't exist.
This is just logic, dude. I mean, I can't really go against it myself.
Yeah, Bev, I understand that you are saying things based on logic, and I want you to understand that I am also saying things based on logic.
Go on, what was
Saying
your
that
logical
what you're
statement
saying
then?
is logical is kind of irrelevant.
Can you state your logical statement then, please?
Yeah. So depending on how you establish the plane of the horizon, it either will or will not be parallel with a horizontal line.
Okay, so how would you establish a plane of the horizon with a tilt that makes it not horizontal? How would you do that personally? Because if you were to tilt it away from you, it would still be on a horizontal, wouldn't it? It would still be parallel. So you'd have to tilt it left to right somehow.
No.
Yeah, you would have to. Otherwise, it would still be parallel to the plane of the horizon.
Were you wanting to give me the logic for why you can't imagine how this would work?
I just give you the logic of why it does work.
Right. So
and prove that you can't. Yeah. I can prove that logical statement.
You go ahead. Just keep pretending to have a genuine conversation.
I've got plenty more proofs than that. That's just one of the basic ones that we did for a laugh, for a t-shirt. But it turned out to be way more than that, obviously. Do you like it?
Do you think
it's in the debate discussion.
I have a question for everybody else. Can you guys hear me okay?
Yeah.
Have you been able to hear me okay throughout most of this exchange?
Most of it, except for that one time you said he was interrupting you and you actually did cut out. But other than that, yeah.
Yeah, I think when I have my live stream on, or the live stream on, he may have roboted a bit. But it seems like now I've switched that off, it's a bit better.
What about the meme, the diagram you had earlier today? Think he could do that, or is it getting too late?
Me?
Yeah.
The diagram earlier.
Yeah, the vertical height for the.
Oh right, yeah. Yeah, this one is.
See if he knows. He might do better.
This is this may be a bit advanced, but
nothing about this is advanced.
Pardon?
I said nothing about this is advanced.
Okay.
Well, let's just step it up a notch.
Okay then. Right, I'll hit the whiteboard in a minute to prove the horizontals to you. See that? It's like a school book question. Old one. Make sure you read it correctly. Laurie got proper triggered by one of the words. Given any water level of unlimited length.
I'm just gonna deafen so I can read it on my own. Thanks.
Okay. Wow. He must be tricky.
Are you going to be a dick through the whole thing, or is it like
He's deafened himself.
Oh, he's deafened. Yeah.
Yeah. Probably, yeah.
I mean, he
Probably.
got onto you about reading with a different inflection in your voice, but then he can speak like a dick the entire time.
Yeah. Well, that's fair enough. I've just got a nip to make a brew. I'll be back in. Talk amongst yourselves for a bit. He'll probably be away for a bit because he's researching it, obviously.
Clary, are you there? No Clary. Turn up. Turnip's a bully. He's also French. He must have fell asleep.
All right, I'm back. So there's a couple of problems with it.
Well, hang on a second. Sorry.
Yeah,
Bev stepped away. Yeah, go ahead. Sorry.
Okay. Well, the answer to A is that it's unlimited because there's no defined length, so it's just unlimited. And then the second answer, the answer to B is that A is just always going to be half, or at least it appears that way. It appears that there's no reason to think that that's not directly in the middle. But the problem with it is that both A and B assume that the Earth is flat, and therefore the surface of water isn't curving. So it's an unbiased, or it's a biased question pretending to be unbiased. So it's just a stupid question.
Would it be unbiased to say that the Earth is a sphere, therefore water curves?
Yeah, I would say that.
It would be unbiased?
But it would also be unbiased to say you don't know, in which case you wouldn't use, it's obvious, you wouldn't use water for this question. Like, typically a question like this is just made.
You could only use water with this question.
This is a physics thing. We stepped it up a notch, bud. Keep up.
You're pretending to have stepped it up a notch. There's nothing new here. This is pretending to be a simple question.
Anything else would have a different number.
I mean, if you keep interrupting me, the thoughts that I'm having to respond with, they're not gonna stay with me.
Okay.
And then you won't get them.
Yeah, we don't want any of that. You keep going then, Louis. Keep going. Don't stop that flow. Come on. Oh, we spoiled it.
Okay, then I just won't talk. You're obviously not interested in it.
Sorry, did you cut out then? Sorry, Louis.
Yeah,
you're free to carry on.
You totally went deaf and like you didn't say anything.
Yeah, that's fine. Connection might have cut out. Carry on with the rest of the presentation.
I nipped away for a second with this question. Are you taking a pass?
Oh.
Yeah, you'll have to say it again.
Yeah. So the issue with the question is that it assumes the Earth's flat.
No, it doesn't. This is a question from reality. It's just pure physics of reality.
Well, okay, if you don't assume the Earth is flat, then there's not enough information to answer the question.
Sorry?
Yeah, if you don't assume the Earth is flat, which I am, forgive me for assuming, I'm assuming that you are assuming the Earth is flat. Am I wrong?
No, we just what's the maximum distance to keep that water level functioning as a water level? If you don't know, it's fine.
So you don't assume the Earth is flat then?
No. Why would anybody do that, Louis?
Oh, that's crazy. Yeah.
Yeah,
totally
because
crazy.
the Earth's not flat. It's not 2D. There's elevation all over the place. There's vertical changes in height.
Yeah, you're very nuanced, Bev. Yeah.
No, just reality, dude. Reality, Louis.
Man. Round of applause for you. You've thought about this.
I have, I've been doing it for ages, but there's a whole team of us working here, Louis.
It's a serious physics question, and you're not answering it. Yeah, it is.
Don't give up yet. Don't give up yet.
If this was a serious physics question, there would be no need to include water level in it. You would just say, given a line with unlimited length, what is the maximum possible distance between B and M?
How would that wouldn't apply, because the water is the physics involved in this.
No, it's not.
It is.
You better think about that before you say that again.
It's not. There is no need to include water in this, and it's cringy that you think you do.
There are tons of physics teachers that do videos on this and talk about it, and there's papers and.
No, there aren't.
Whoa, Bev, I'm sorry. I honestly thought this was like going to be better than the last conversation we had. I apologize.
Yeah. Do you have any examples of physics teachers just chatting it up about the surface of water with this type of question, and they're like, "Oh yeah, this is physics, guys."
Absolutely, Veritasium's done videos on it. Like, loads of people have done videos on this shit. Loads.
Yes.
Oh, Veritasium. Oh wow, can you post that video?
No, you go looking for it for yourself, dude.
Yeah,
please do.
That's fine. That's fine. Yeah. Veritasium is specific enough. I'll probably be able to find what it is you guys are talking about.
No, you don't have to do it like that. It's not like a go away and find us the answer. It's okay. This is just a simple question.
It won't even take me very long.
Wow. Okay. Well, I'm going to go and make a brew if somebody wants to. I get a feeling this might be a cog diss thing, Louis. But,
you're right, Bev.
You do seem to be
that cog diss stuff.
You do seem to be on tilt, Louis.
Something like that.
Yeah.
Wow. I can't believe you said that.
Unreal. I've never seen anyone like this before.
Now you're interrupting.
Oh, I'm sorry.
So you don't think something would happen with the water at a given height? Within that tube?
I don't think something would happen with the water at a given height.
Okay. Are you asking me the question I just asked you?
Yeah, I'm confused about the relevance.
It's imaginometry, that, isn't it? It's that's wrote into the imaginometry.
It's not even part of the question, but you're asking
seem to be following the script.
It's in the question, the height of the.
It is not in the question. There is nothing referencing height in the question.
Dude,
you give away part B.
What is A?
Sorry. I thought this was going to be a step up and we were going to get like better answers than the last conversation we had, but
well, when you get to determine what a good answer is, you can determine what a good answer is.
Yeah, I'm like Bev. I'm not going to answer it for you because that's wow.
You wouldn't believe it. You'd just go against it and say it was a lie.
Well,
so
it's a lie.
You have to find it for yourself.
What would I say is a lie?
Whatever we said to you, because you seem to have done that most of the time.
No, I wouldn't say it was a lie. A lie implies intent.
Okay, well, that's why we're not going to give you anything. You can do this, Louis. You can. You have the ability within you to find an answer.
Bev.
But we can carry on if we want.
The answer you guys want is not the correct answer.
I can show you. Let me put my camera on. And I'll get you on the board. And I'll show you, because I think, are you having a problem with lifting the bit up in the middle on a water level?
Where is the water level? You mean the
from B to M, there is a water level. There is a maximum height of A above that water level. Now,
that is not, Bev, that is not being asked for in the question.
What
can be said?
What is the maximum distance possible between the level BM and the point A? At the bottom, look in the bottom one. There's B, and there's M, and there's A. And then there's two little right angle things at the bottom.
I had no idea those things were on the picture I was looking at. Thank you,
well, why? Okay, well, no problem.
Yeah.
Anytime, Louis.
That changes everything about how I'm thinking about this now.
Brilliant.
So the answer to A is that it's unlimited, and the answer to B is lots of things, potentially. There's a lot of things that can be said about those three things.
That's a soundbite. A is unlimited.
Yeah.
For sure.
All right, I'm sorry. The distance between points B and M is unlimited.
What about the distance at A?
It's also unlimited.
There you go.
Oh.
Yeah.
Yeah.
Well, you are definitely going to fail physics.
Well, if I think the Earth is flat, yeah, you're right.
Wow.
It has nothing to do with...
Is that what's stopping you from saying there is a distance at A? Is because you might have to think to yourself that the Earth's flat, which it obviously isn't, but that's what's stopping you from coming up with an answer?
No, Bev, it's because what I know to be true is not in harmony with the assumptions made about what you believe to be true when you made this question. And so for me
I
to
didn't
come
make
up with
I didn't make the question.
For me to come up
I
with
didn't
an
make
answer,
the question.
You didn't make the question? Okay.
No.
Whoever made this question made assumptions about reality that I don't make, and the ones I have are in contradiction with it.
Can't get me camera to work.
So for me to answer this question, I have to disregard what I know to be true.
Okay, well, what do you know to be true then?
The Earth is a sphere.
Okay, and what answer does that give you?
As a result, the distance between points B and M cannot be unlimited.
Oh.
And as a result, that changes what can be said about point A.
And what does that mean?
Well, the point A, you've already let on that you want me to give the difference in one dimension of how much further out of a dimension A is from the line from B to M. And so that distance, if the Earth is a sphere, which I believe that it is, that means that distance is the radius of the Earth.
Wow. What's that then? Maximum distance that for an operating water level is a radius. Have you got anyone that...
Have I got anyone that's built a water level that's the size of the fucking Earth? No, I haven't, Bev. Okay. Is this the presentation?
No, I was after, because you said a distance. Have you got anyone that has measured that distance?
Oh, that's what you're asking.
Yeah.
No, I haven't, Bev. Is this the rest of the presentation?
No, I'm trying to get my camera working.
Okay.
I'm really struggling.
I was under the general impression that what I would be seeing here was an actual experiment.
Oh, were you? It's just a proof what you from first principles. I said, didn't I?
Oh, so it's proof from cherry-picked assumptions.
No, it's proof from
it is. That's exactly
mathematical.
What it is.
You've just denied a few of them.
No, I haven't denied any of them.
Of course you have.
You've denied principles.
I've given you
none of the principles you said.
You've not given us anything.
None of them. I didn't disagree with any of them.
you didn't.
That's correct.
With what? What was it?
Every single principle you gave, the only criticism I gave was that it was too wordy or redundant. Every single other thing, I said, yeah, that's technically true. You are the one who has denied other principles, like that circles can be perpendicular to each other.
Right, I've heard a lot of people say that, but I think it's a bit silly.
I bet you have. Why do you think that might be?
What, I think it's a bit silly.
No, that you hear so many people say the same thing to you.
Because there's loads of people that are triggered the fuck out of this shit, and they keep injecting balls and circles into things all the time. When they're really saying perpendicular, it's just two straight lines. You're just drawing circles around them.
You might interpret their reaction as being triggered, but there's more to their response to you than just maybe elevated emotions. There's more to it.
It's a cogdice thing.
It seems to me maybe you're avoiding thinking about what else there might be involved in these interactions.
I just go with the mathematical definitions for...
Oh, right, yeah, the cherry-picked
the ones that I can get proofs for. Yeah, just get the ones I get proof for. Can you see my camera?
Small few ones that confirm your bias, the things that you already think are true.
Can you see my camera?
Sure can.
Okay, brilliant. We're ready to go then. Let me just bring this over here. Switch that on. Boom, is that better? Ooh, here we go. I've got one here. We like to do a bit of logic. Right line geometry.
Wow, yeah, that's really geometry, that's man.
The only geometry that's provable in reality.
Oh wow, yeah, that's pretty cool.
It is, right? You ready for this now?
It's striking. I go through my day-to-day life, and nobody's thinking logically.
Are they not?
No.
Doesn't surprise me. You go to Gem Pandas a lot.
Yeah, everybody that I know, like, they just kind of randomly stumble through life without thinking.
Yeah, like I say, you do go to Gem Pandas a lot.
Yeah, everyone over at Gem Pandas is kind of there's no logic to anything, yeah.
Well, if you say so.
Yeah, it's so refreshing to see you think logically.
Your friends over there. You don't seem to.
What's that?
Are they your friends?
I would not say they're my friends. I would say I have friends over there, but no, I would not say.
Do the water
generally
level
speaking that the people at Gem Pandas are my friends. No.
Louis, do you know what a water level is?
No, I watched this presentation you just gave. I still have no idea what a water level is.
Well, luckily enough for you, we've got one here. It's a water level.
Oh wow, yeah, that's really something.
Yep. See what happens when you do this? You move this one down.
Oh yeah, oh wow, that's crazy. The water changes levels inside to equalize.
Yeah, it's good that, isn't it? Right.
Yeah, completely caught me off guard.
They find a level. They find their own level, don't they?
It's more like maybe
equal pressure, and then this one can come over here.
It's like maybe they're finding an equilibrium based on the forces acting on them.
This one go over here like this.
Yeah.
Yeah? You like that? So they don't look like they're on the same level, do they? But they are actually level, because the water level, that's what water levels do. They equal out. No matter.
Crazy.
Now, how long do you think you could make this tube and this water level to be able to establish its own level?
Yeah, as long as you had material to make the tube.
Okay, so it could be of unlimited length, right?
That's correct.
Okay, now see the way this does this as well.
Yeah, I see that. Yeah.
So the water level always establishes a horizontal, right? Plane across the two.
Yeah.
Okay, so we know how water level works. And because there's 2 points... Because there's 2 points, we can... It's like drawing a line, isn't it? Straight line. At one point to another. Yeah, of course it is. This is mathematics.
It's not.
Yeah, it is. This is how you establish a straight line from one point to another. The shortest distance from here to here would be the shortest line, right?
All lines are straight, so the shortest line's kind of redundant.
Now, see this. You know that test that we were showing you before?
Sure.
Don't be doing that. Piss water out. This goes... Right, this goes up here. Now, how high do you reckon this could go for this to still establish a level?
Oh, that could go up real high. Eventually what would happen is a vacuum would form at the center.
Oh, really?
Yeah.
A vacuum?
Yeah.
Okay. So at what point would the vacuum occur?
I think it's at like 34 feet or something.
Okay, nice. Well done. So we do have an answer now then, right?
Okay.
Okay. Do you know why it does that? Who did you get? Shout out. Was that Gem Panda? Did he give you that?
No.
No. Who was it then?
That was just education.
Okay. So you just found it, or did you know it all along? And you just string us along?
I did. It is something that we were taught in school, but
wow.
there are a few places online that you can see it. James Burke has a series of TV episodes that are sort of documentary type things, and it references it in there. There was I don't know, one of these famous science dudes.
Veritasium.
What?
Veritasium.
No, if he made a video on it, it would not surprise me though.
Okay, so it's a well-known, established fact that, I don't know, you say a vacuum, I'm not so sure it's called that. I'd say it reaches a negative pressure state in where cavitation occurs, and the cavitation.
I mean, it's not going to be a perfect vacuum, but
cavitation at the negative pressure state causes an airlock to stop the water level from working, right?
Yeah, I mean, it won't stay a vacuum for very long because the water will boil at that.
Cavitate, yeah. Turn into air, causing an airlock in the center at the highest point.
That area.
Right? Yeah. That stops the water level from working. Yeah? So you just answered question 1. A. Well done.
No.
Don't be telling everyone though, right?
Well, look, if
but you
that
did very well.
Is what you wanted the point of the question to be, you didn't make that obvious at all.
I didn't make that question. But you did well.
Bev, who made the question?
No, whoever made the question. It's a good question.
Okay, look, Bev. Okay. It doesn't matter who made it. It's the presentation you're giving, okay? And I'm telling you, if that is the point you're trying to get across, you're not asking the question in the correct way.
Go on. Help us out then. What's the better way to ask the question?
Have an introduction about exactly what we just talked about how if you have a tube like this, there's a maximum distance that the water can be drawn up the tube.
Water can be drawn up?
Yes. You could have an air pump on one end of the tube, or just a water pump on one end of the tube. Because a water pump would act the same as an air pump. But you could just have a pump on the upper end of the tube, and just the other end of the tube is submerged in water. And as soon as the top end of the tube is above that 34 feet or whatever, then it's not going to be able to pull it up. No matter how powerful the pump is, it will not be able to pull the water up.
Oh, Sleeping Warrior was talking about that suction from a pump.
Yeah. That's why if you want to get water up that high, you have to either have a series of pumps or you have to put the pump down in the water at the bottom end.
Well, I would suggest that the theory goes that you can siphon water and get it to go up 30 odd feet before it comes back down again, right? And at that point, it stops being able to siphon with that upward.
That may be true. I don't know though.
Yeah, it's a similar thing, right? But I mean, it's water doing it of its own.
I bet you're right. I bet you're right about that. I bet you're right.
Well, I don't know whether you'd win your money or not. It's just a point of view, right? But you got the first part of the question. You've done it. So, what we do is we get a water level. Right, and it just establishes a level. Now, would you say if we were put DP here, then would this one, because you did say it's horizontal, right? It's not going to drop, is it? Like one end of these water level, no matter how long it is, cannot be lower than the one here, can it? Like this one. This one can't be higher than this one. This one can't be lower or higher than this one, right? They're both at the same even altitude.
Well, this whole thing is obviously going to where you make the water level so long that the hump in the curve of the earth becomes greater than this 34 feet, right? And then that means, well, now.
Oh no, I wasn't thinking that. But I mean, that's a good idea. Because what you're saying is you can't have that hump from level to level, right? The hump can't go above 30 odd feet, right?
Unfortunately for you, that's not true.
Is it?
If you
just said it was, though. You said people have made videos about it.
I've never said anything contrary to the point I'm making right now.
Okay, go on then.
You could, so you make this water level, I don't know, like 5 miles long or something, however long it needs to be. I mean, you could do it 1 mile, but the hump wouldn't be very significant. It'd be like 4 inches or something, right? So then the maximum height that these little level sections at the end of the levels could be is restricted. So if you make it 5 miles, then those can be a little bit longer, and then this whole demonstration becomes more obvious.
Okay, well, what sort of distance do you want to put on this? And
5. Just 5 miles is good.
5 miles on a water level.
Yeah.
Right.
Yeah,
have you done the numbers?
No, we can do them quickly though. So
I know the numbers for.
Then just
do 2 miles, right?
Okay, sure.
Okay, so say,
if you...
where's my pen gone? Yeah, this is 2 miles, right? 2 miles end to end. The water level. The water in it levels out to be an even altitude all the way across from one end to the other.
Yeah.
Right, now, for instance, what would happen if we took this one and we put it here? Would this be 1 mile, and it would still be level, wouldn't it?
Yeah, exactly.
Okay, so you could put put this one anywhere along here, because this is the maximum length of the tube.
Right, and you're always going to be able to find level with it, and you're going to be able to see that it's the same elevation no matter where you do it.
Okay.
And that you can continue that with the tube being, hundreds of miles long.
Yeah.
Like there's no limit. Theoretically, there's no limit to how long you could make this. Unfortunately, I fear you're trying to use this as a way to show that, well, there's no curve, because if there were, they wouldn't be at the same level. And unfortunately, elevation and a straight line, just because two objects are at the same elevation, does not mean they're that if you draw a straight line, every point on that line will be at the same elevation.
Does it not?
No.
Okay. Well, like you say, we're going with this water level at the minute. This was my first one. Now, because we've gone 2 miles, they say, I guess you have numbers, right?
Yeah, let me...
Do you know what the... I don't know, you might get a bit tricky. Because your 2 miles it can't be drop. You're not going to say there's a drop, are you?
No, it would be from the center.
Okay, so yeah, we're doing away with the drop. Definitely no drop. This is an even altitude. So what we're looking for a hump, yeah?
Right, yeah.
Okay.
No.
Yeah.
When you,
okay.
I'm not sure.
Well, we'll go green for the hump. Oh.
I'm not sure exactly what you meant when you said there's no drop. But
you've got numbers, haven't you?
No, I said I didn't have numbers. I'm saying that I can loosely figure them out quickly.
Okay, then. Well, what's your number for 2 miles? Because you have a drop number, don't you?
Yeah, from the center, I think it would just be 8 inches.
8 inches up, though, right?
No, not up. It would just be relative
to.
If you were to draw a horizontal line.
Yeah. Like
from the center.
Like that.
Yeah, if you were to draw a horizontal line from the center, this far, both of the levels would be 8 inches beneath it.
But this is a horizontal line.
Yeah, that's correct.
Yeah, and it is the one that's making the water level.
No.
Oh, okay. Well, I'll take that away there, right, for a minute. We've got the water level and it's full up with water, right? From one end to the other. Now, you have you have an 8 inch. It's not an 8 inch drop here, is it? It can't be an 8 inch drop. So, if this is an even altitude, then if we put one in the middle, like this, tap one in.
Yeah.
Tap it in. Oh, I'll do it all the way up here for you, right? Now, bear in mind. I'll give you this.
Yeah, draw it even with those.
Even?
Yeah, draw it even.
So here?
Yeah.
Okay. That's where you go with, right?
Yep.
Okay, now. So, where's your 8 inches?
So in reality, if you were to draw a horizontal from that middle one, that line would be 8 inches higher than the water level is showing at the far ends.
But that's what we use to establish this one here.
Yeah,
so I know. So you're saying as soon as we put water in here, that these ones will drop?
Here's the confusing thing, because elevation is determined from your distance away from the surface. So if you've got the surface of water, your
water,
elevation
is
just going to be.
Look, it's here. There.
Yeah. I understand.
There. Right.
I
can't do anything with it.
I understand that, Bev.
Okay.
If you imagine that if you put this whole experiment next to the surface. It's
not an experiment. This is a tool for establishing level. It's not an experiment.
Bev, just listen to me for a second.
It's an experiment. I've been doing experiments here all this time. You should be amazed at how many experiments I'm doing.
Listen to me for a second, okay? if you took this whole experiment and you put it into a body of water, so the water inside the tube is not mixing with the body of water surrounding it, and you just raise this whole thing up just a little bit so that it's just slightly above the surface of the water, a few inches or so.
Move it up parallel lines.
Yeah, that's fine. So the far ends, they're a couple inches above the surface of the water. The middle one's a couple inches above the surface of the water. If you then if you were able to draw a horizontal line from the center and extend it all the way out to the far ends, that line would be 8 inches higher than the level of the water that is indicated by these outer edges. By not by the body of water, not the level of the body of water.
Yeah.
But the water inside the tubes.
Can I ask, why didn't you go 8 inches above this?
Because the
to
elevation.
Show that these were 8 inches down.
Because
why did you go at the same?
Because the elevation is determined based on your distance away from the surface, and the surface is curved.
Surface?
The surface of the Earth, Bev.
Oh, we wrote this one here. Elevation curvature is radius dependent. Do you like that? Is that a good logical statement?
No, I don't.
Isn't that
Bev.
what you've just said?
All that means is that the size of a sphere is dependent on the radius. That's all that means.
No, it doesn't. No, it doesn't.
Yes, it does.
No, it means the rate of curvature, obviously, as it gets bigger, the curvature changes. So the radius, as the radius extends, the curvature gets like less, or because the circle gets bigger, right? The curvature, like even imagine if it's a little tiny circle, it's like that, like this. Like this. Look at the curvature on that. Look how tight that curvature is.
Yeah, Bev, if you were...
Like,
if you were the size...
as the radius gets bigger, look at this.
Bev,
look at this.
I'm sorry.
The curvature of these two different. They're different because the radius is different.
Bev, how much it's curving only...
I was sort of agreeing with you. And you've cut out. He has cut out for everyone.
Yeah, reconnect, Lewis. I think he dropped out.
It looks like it.
Oh.
Out.
Can you hear me okay?
Yeah,
we can.
You're good.
It only it's curving more because it's...
No, you're roboting for me.
Yeah, now it's pretty bad now.
Okay.
Yeah, that's much better. Hopefully.
It only looks like it's curving more because it's smaller.
That's on a straight line at the minute.
Yeah, I know it's drawn on there like it's a straight line.
That is a straight line.
In reality, I'm just telling you what would happen in reality.
Yeah, straight line. Horizontal.
No, you would not be able to draw a straight line.
Horizontal, Louis.
Bev, you would not be able to draw a straight line connecting the 3 levels.
Why not? You've put them all on the same straight line. That's what they establish. A horizontal.
Bev, this is a drawing.
Pardon?
I said this is a drawing.
Yeah. This is exactly how you told me to draw it.
Yeah, I wasn't drawing it based on reality.
Why not?
If we want to draw it based on reality, you'd have to create an arc.
Okay, so how do you do that? This is a water level. We tap one in the middle. What happens?
Erase what you've got there.
Erase? Can I do? What am I doing?
You erase everything you have.
For what reason?
So that you can redraw it the way it would be in reality.
It's a water level. It's already here. Water in it. Water in it.
Right. So the reason you're going to erase everything is because if you want to draw it the way I'm telling you it would be in reality, you have to erase it so you can replace it with my concept.
Oh, right. Okay. Concept drawing. Louis' concept.
Yeah, you know, I have a suspicion that because I used the word concept, you're taking weight away from it. But you should acknowledge that everything you have in your head is a concept as well.
Okay, are we going to keep
Well, you were
with the
talking about
two
reality.
whales?
Are we talking about reality or concept?
We were talking about reality.
Anytime people talk about what they think, it is always concept, whether it's explicit or
Louis, who are you talking about? They. This is yours. You want me to do it your way. We're doing it your way now. This is nobody else's, is it?
Your interruption for my brief response to Cleary is entirely unwarranted.
Okay. Don't forget, I'm the one that you want me to draw your concept on my whiteboard.
Yes.
Okay.
Yes, that's correct. And you're ready to draw now.
Yes.
Okay. So you're going to start by drawing a shallow arc from the same amount of space that the previous line took up. And just, you know, the top of the arc should only be a couple inches or so higher than the edges of the arc on the board.
I'm drawing it like this? Or am I drawing it like this?
You're just drawing it bigger. It's just an arc,
yeah,
but it's going to be bigger than your...
Which model, please, Louis? Hump or drop?
Hump.
Hump. Okie dokie.
They're both the same model, but I understood
one's
what
a
you meant
hump
by
and
that.
one's a drop. They're definitely. That's why I asked you, which one do you want me to draw?
Well, both of them would be the same.
No, one of them's the drop and the other one's the hump. That's why I asked you.
No, they would be the same. It's just saying
look,
drop means
I'll do this for you.
Yeah.
That's a drop.
Yeah. Exactly. It's just not centered.
Is that what you want? Is that what you want? That's
no, I want the one that's centered on the board.
No, they're both the same. That's the same. Let's go. Yeah.
Yeah, they are both. They're both the same. One's just not centered.
Well, let's go then.
So we should just. No.
Like this.
Erase that. Bev, erase that one that's centered.
They're both the same. Come on.
No, one is centered.
No, this one look the
same.
You said they're both the same.
No, Bev, you know that drawing the one that's centered is going to be easier to do.
Oh, easier for you. Yeah. Okay. So you can imagine level. Okay. Yeah, I've said this before. Yeah. I hope we understand.
Good grief,
Everyone
man.
understands that.
Hey, you know,
you like to think that they're the same, but they're not actually the same. We know that. I
want to tell you, this is unrelated to our discussion here, but you're a much more likable person on camera.
Thanks.
Yeah.
How's about that then? Is that a bit better? It's not the same. This is the hump model.
No, it is. Bev,
this is the hump.
The fucking same. It is.
Of course it is. This is not the same as that other one.
Yes, it is.
Dude, no, it's not. I had to put the compass here in the center to do this, and I had to put the compass here on this side. It's not the same circle. It can't be the same circle. It's got different centers.
Oh my god.
Okay.
It's the same. If you had an unlimited size, if your whiteboard was big enough to draw the entire circle, as long as you made the radius the same, they would be the same size circle.
It wouldn't be. It would be here or here. But this way, it's okay. This way gives you a chance to imagine horizontal actually being horizontal. I know.
Goodness, dude. Okay.
Everyone goes to the hump.
So, like, just draw on the far ends and in the middle, draw little protrusions, little lines that are the same distance off of the arc.
A water level is what we're doing. Because we're doing it in practice in water level reality. Okay?
Right.
Yeah. So the tools we've got
just like
is
make them an inch.
A water level.
Make all of them an inch, just for consistency. Make all of them one real life inch.
Okay. So we've got a water level there and a water level there. Now, what sort of distance have we got? Is that an inch? Is that big enough for you?
That's good. That's good. And then draw a third one in the middle.
Up here or down here?
Yeah, up there, on the curve.
Tell you what I'll do, just to give you it. It will go like this.
No,
Yeah.
no, Bev.
Yeah.
Draw it the
No,
same
what
size.
we do is we do this, and we go like this.
No.
And we just put water
Bev,
in it.
Right.
Tell me where you want me to fill the water up. I'll put some water in it here.
No, God damn it, Bev.
Put some water in it here.
No, this is not what I want.
Where does this go? Where does the water?
No,
when we fill
Bev,
the water up here,
Bev,
here,
stop it. Listen
where
to me.
does the
You're
water
ignoring
go?
me. Bev, you're ignoring me.
It
Draw
gives everybody
the
free
middle
rein to
one
do
the
whatever they
same
want.
size as the outer ones and draw it on the curve. Draw it on the curve, Bev.
It is on the curve. You can choose
Bev,
how much water you put in
Bev,
it.
you know exactly what I'm asking for.
Yeah. Where does the water? When we put water in here, where does the water
you
go
cannot
here?
be doing
Come on,
this,
Louis.
man.
Tell us.
Draw it on the
here.
curve.
Yeah, I'll go like
No.
here.
Oh my gosh.
That's where I think. Where do you think
you
the
know what
water
I'm
would go,
asking
Louis?
for here.
We know you've never done it.
No, Bev,
So
draw
where
it
do
on
you
the curve.
where do you think,
Draw
or
it
where
the
do your
same
friends tell you the
size.
water goes?
Bev, draw it the same size on the curve.
But okay,
that is what I am asking for.
well, okay, here. You want the water level here?
Yes.
Okay, easy like this. Dead easy.
Is that a hill?
Oh my gosh, no, Bev.
Is this a hill
The
we're looking at?
entire instrument. The entire portion of the instrument needs to be up on the arc. It needs to follow the arc.
It is.
No, it's not.
Oh, can we could do this though. How about this? Whoop. Whoop. How about we go like this? Ooh.
What?
How about we go like that with our tube? It's a
Bev,
water level, isn't it? I mean, as long as this bit here doesn't get 30 odd feet
You know
above
what
it,
I'm
it still
asking
work.
for, man. Just draw what I'm asking for.
That's a really good point right there, Bev. Did you catch that, Lewis?
Put 0 at the top, maybe 33 feet.
Mm-hmm.
What?
Yeah. How far have we gone here, Louis? How far have we gone?
Draw it the way I'm asking.
How far have we gone, Louis? What distance between here and here?
This drawing is not representative of what I'm trying to get across.
This is a brilliant experiment for you, Louis.
I
think you should get Jem to help you with his super chats to sort this.
We should call this
out.
the Louis.
Yeah,
Bev,
this is the Louis. The Louis.
Bev, this is not what I'm trying to get across. This is not what I'm trying to depict.
Louis, just remember, we're not laughing at you. We're just laughing at the fact you're trying to make a horizontal line arc.
Rakia, I'm not trying to laugh at you either.
Okay, but you're trying to tell him to put a horizontal line as an arc.
Rakia, he told me he was going to draw this thing the way I wanted, and he's not.
You agreed that the water level was a horizontal line. Now you're trying to arc it, sir.
Yeah,
Rakia, this isn't about
that's where you wanted the
definitions
water
that I
level,
agree
right?
were technically correct. This is about the depiction of reality that I wanted him to draw, because what he drew before was not what I considered a depiction of reality.
Yeah.
Hey, carry on. I'm enjoying it.
Are you saying, in your concept, this wouldn't work? Like this?
I'm saying that this picture you've drawn is not representative of what I am trying to get across.
Would the water level not follow this curve of yours?
What I'm saying, Bev, the picture you've drawn is not what I have in my head.
Wow. Well, I'm never going to be able to do that, dude. You can't.
Yes, you are. You almost
do a drawing.
did it.
You do your
almost
drawing.
did it. Bev, you almost fucking did it.
What do you mean almost?
You stopped. You chose to draw it this way.
Yeah, because the water level follows the curve.
Bev,
it's exactly what you wanted.
Bev, okay, I've got a yes or no question for you. Are you trying to accurately represent what I'm trying to get across?
You want the water level to be here,
That was a
here,
yes or no question,
here.
Bev.
This is all that matters, Louis. It's the only thing that matters with a water level.
Okay,
is where the level of the fucking water
Bev,
is.
listen to me. Listen to me. You're telling me that what I'm trying to get across does not matter?
No, I'm trying to tell you do you think the water level
is
the important thing in these water levels?
Shut up.
Or do you not
I'm
think
going
the
to
water
leave if
level's
you don't
got
let me
anything
get this
to do
out.
with it?
Bev, this conversation is approaching the point of being pointless. All right?
I think it's already been there right from the beginning, Louis. From the moment you came in, mate.
All right, are you just not going to let me talk now? Okay, thank you. We got to this position right here because the drawing you had on there first was not what I agreed to. It's not. I didn't think that was an accurate representation of reality. And you said that, well, why did you have me draw it this way? And that's because I wasn't thinking about it being accurate. I just wanted to focus on certain elements of it that technically would be accurate.
Okay.
And so then you said, okay, well, let's draw it the way it should be in reality. And so that's why we're here. And I'm telling you,
it was
the drawing
reality
you have
drawn
made
just before, Louis. You
Bev,
said, scrub that reality.
Bev, I'm going to leave.
Oh, okay. Fair enough.
The drawing you have made here
was it this bit that
is
triggered
not
you?
Bev. Let me finish the
this,
statement.
Louis?
Are you going to let me finish this statement?
Well, go on then. Monologue.
The drawing you have made here is not what I asked you to do.
Okay. Now, what's important about these water levels?
No, Bev, okay. Yes or no? Are you going to draw what I want you to draw?
Is it the wrong color?
I've enjoyed most of this conversation so far. I'm just going to leave.
All right.
All right.
Okay. Yeah.
I'll talk to you later.
You nearly got there, Louis. Nearly got there. What do you reckon it was, guys?
Dang it.
Well, the limit right there is it's going to be horizontal below the limit.
Yeah.
Right?
Well, but as a matter of fact, right, since he's gone, he wants the water level to be following this, and the water level is following the curve. So what do you think he wanted that isn't in this drawing?
Curving water.
But it is. Water level's coming all the way up there. It's just, I think what this shows is how ridiculous this bit is. He wanted this to go like that with a little tiny bit there.
Mm-hmm. Yeah.
That's it. But that's not what would happen. Right? You could make these ones as long as you wanted, couldn't you?
Yeah, but he had a concept in his head.
Yeah.
Not reality.
Yeah.
No, not a concept. He said it's his concept.
Yeah. Yeah.
I was trying to get in with my other account, 3Space Turnup. I don't know if you can approve me.
In the where?
I was trying to get into MEUK because I was trying to record and be on my phone. The second account.
Oh, yeah.
Right, so we never actually got to show him the test again. Nearly, though. That's probably one of the
best.
Yeah, he got caught. he got caught in his reality right there, and then he was like, "Whoa, this ain't working out." Back when you had the straight line drawing, he was like, "Erase everything, erase it, take it all away from."
Burn it.
What I'm trying to tell you, you gotta erase everything.
Burn it all down.
Yeah. Oh, man, sorry.
I don't see his reality.
I thought it was funny when he fucking told Bev where to put that middle fucking level. And he was putting on the fucking level. It was level with the other two.
Well, that's 2 hours. Stop recording. Thank you very much, Louis. Anybody else is willing to come and have a try? I'm not so sure whether we should put this out or not. What do you reckon?
Not just yet.
Yeah, no. Save this for...
Okay, for a bit.
You gotta say you're blowing my mind right now.
You twat. How do we know the Earth is not flat? that was
understanding of the world in which you live, then of course the world looks flat. The world looks flat. The world looks flat.
Neil.
Bitch. You twat.
I gotta say, you're totally blowing my mind right now.
That's what I do. 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 What I do.
But I don't have much patience for anyone who denies that this challenge is real. We don't have time for a meeting of the Flat Earth Society. Flat Earth Society.
My friends, these people are so out of touch with science. You don't need to be a scientist to know that the Earth is round.
They must have been founding members of the Flat Earth Society. They would not have believed that the world was round.
Like water. Now you put water into a cup, it becomes the cup. You put water into a bottle, it becomes the bottle. You put it in a teapot, it becomes the teapot. Now water can flow or it can crash.